promised you guys that I would show y'all how to balance reactions, and this would be the notes. So when you balance equations, I know that I taught y'all in class the skittle method, using skittles or any other kind of, round object to represent atoms on an equation, but sometimes the equations can get really complicated, and at that point the skittles method kind of, it wears out its welcome, really. And so I came up with MINO. And MINO is an acronym to help you, and this is not a, steadfast, it works every single time kind of thing, but it does work enough of the time that it is a good little trick to use. This is how to remember the order in which you balance chemical equations. You always want to start with your metals. Now, of course, you need to kind of know your periodic table and know where your metals are and where your nonmetals are to be able to do this. But start with your metals because they do tend to be the easiest to balance. Then balance your polyatomic ions. And what I mean by this is if you have a polyatomic ion that goes from the reactant side to the product side without getting broken apart, then balance it as though it is like one whole entity. And once we start doing practice questions, I'll kind of show you what I mean by that. Then once you've balanced your metals and your ions, move on to the nonmetals. And this includes all of the nonmetals except oxygen and hydrogen. And you pretty much always want to save these two guys for last. Now, it doesn't matter if you do oxygen first or hydrogen first. Just save them for last. I'll kind of try to explain why later, but this is just a method that I have used over the years. I've never seen anybody else use it. I've never seen anyone teach it this way, but it has helped me, and it has saved me a lot of frustration. So, writing equations. If you want to, I mentioned this in the last set of notes, if you want to write the word equation, it can help you figure out and organize what is a reactant and what is a product. On the first couple of examples that we're going to work out, I will write the word equation just to show you what it looks like. If you decide that it is not helpful for you, then don't use it. If you decide that it is helpful for you, then by all means. So once you have your word equation, or you have underlined, I prefer to underline in the word problem, then make sure you know your states. Write the correct formula for each compound. If you need to refresh your memory on how to write formulas, then you need to go back and review the Chapter 7 notes. You absolutely, positively must be able to write perfect formulas before you can do a chemical equation. And then the last step is to balance the equation. So all I have left is examples, and I tried as much as I could to include pictures of every single equation that we're going to write, and almost all of these equations are chemical reactions that either you guys will do or I will demo for you during the Chapter 8 review. So, first one. Zinc metal is added to hydrochloric acid to create zinc chloride and hydrogen gas. So the first step that I'm going to show you guys on this is to write the word equation. So your reactants, you have zinc metal. Sorry about that. Add zinc metal, so zinc plus hydrochloric acid to create zinc chloride and hydrogen gas. So this is a word equation, and it can help you write the actual equation, especially until you get good at recognizing what's what in here. So now we're going to take this and move on to the actual equation. So zinc metal, pure zinc metal, would just be written as Zn, and it is a solid because metals are solid. Remember, if it doesn't give you a condition, temperature-wise, pressure-wise, you can assume that it's at standard lab conditions, about 22 to 25 degrees Celsius and 1 atmosphere of pressure. So then we're going to add it to hydrochloric acid. The formula for hydrochloric acid is HCl, and anything that is an acid is going to be aqueous. Well, most acids are aqueous, I should say. To create zinc chloride, well, zinc is a +2 charge. Whoops, sorry. Chlorine is a -1 charge, so the formula for zinc chloride is going to be ZnCl2. And this is going to be, because we had an aqueous over here, this is actually going to be aqueous. And you're probably going, well, wait, no, this is an ionic compound. Ionic compounds are solids. And you're right, they are. But the majority of ionic compounds will dissolve in water. And since we had water present here for the hydrochloric acid, well, that water didn't go anywhere. It's still present over here. So the zinc chloride is now going to be what is dissolved in the hydrochloric acid. And then we're going to add to that, we're also going to make some hydrogen gas, which you can see right here bubbling up nicely. And because hydrogen is Brinkelhoff, we're going to write that as H2, and like it said, it is a gas. And so now we're going to balance this thing, going with Mino. I'll write it up here just so y'all can remember. Metals go first. So I'm going to look here. I've got zinc, hydrogen, and chlorine. Those are my 3 elements participating in this reaction. Well, zinc is the only metal that I have. So I'm going to look at my reactant side, and I see that I have 1 zinc. Now I'm going to go over here to the product side, and I find my zinc, and I see that I only have 1 zinc. So the zincs are naturally balanced. Yay! And now I'm going to move on, and I'm going to see if I have any polyatomic ions. Well, I'll look at my reactant side, and I don't see any polyatomic ions, so I'll get to skip that and move on to my nonmetals that do not include oxygen and hydrogen. So all that I have left is hydrogen and chlorine. Well, that means I'm going to balance my chlorine next. So I have 1 chlorine on the reactant side. Come over here, I have 2 chlorines on the product side. So the way that you balance this, I need to have 1 more HCl on this side. So I don't need to have 1 HCl, I need to have a total of 2. And so now I have 2 chlorines because this 2 distributes to whatever it is that comes after it. And so now I'm going to move on to my oxygen and hydrogen. Well, I don't have any oxygen, so I can just do hydrogen. Well, you can see here I have 2 hydrogens, and I go across to the other side, and I have 2 hydrogens. So this is balanced. Moving on to the next one. Okay, I have solid calcium metal reacts with water to form aqueous calcium hydroxide and hydrogen gas. So, solid calcium metal. I'm going to show you how to do this with underlining it. Calcium metal, and it is solid, reacts with plus water to form, there's my arrow, aqueous calcium hydroxide and hydrogen gas. So I'm going to start solid calcium metal. Well, calcium is a pure element and it is not part of Brinkelhoff, so it's just Ca solid plus reacts with water. Now they did not give us any conditions, so we can assume that it is at typical laboratory conditions, which means that water is a liquid. To form aqueous calcium hydroxide. Well, if you remember, calcium is in group 2, so it's a +2 charge. Hydroxide is a polyatomic ion with a -1 charge, and so you have CaOH2. Add to that some hydrogen gas. Remember again, hydrogen is part of Brinkelhoff, so it's going to be H2 gas. And I totally forgot, I'm going to insert in here aqueous. Forgot my state right there. So now I'm going to balance it, starting with my metals. Well, I have calcium, hydrogen, and oxygen. Those are the only 3 elements that I have. I know that I'm supposed to save hydrogen and oxygen for last, so I'm going to start with calcium. So I got 1 calcium on the reactant side. I have 1 calcium on the product side. So yay, they're balanced. Now coming over here, hydrogen, oxygen, you know, doesn't really matter which of these 2 I start with, and I typically just start with the first one that I get to. So I have 2 hydrogens here, and I have 2 hydrogens here plus these 2 over here for a grand total of 4. So I have 4 hydrogens over here. I have 2 hydrogens over here. Well, I typically use, not typically, I always use what's called least common multiple, LCM. Remember that from like 5th grade math? And to figure out what I needed, what coefficient needs to be added. Well, what's the least common multiple between 2 and 4? Well, that's going to be 4. And so I've got 2 over here, so what do I have to do to a 2 to get it to be a 4? Well, I have to multiply it by 2. So now 2 times 2, because whatever coefficient is out front distributes to all of the elements that are a part of the compound that it comes before. And so 2 times 2 gives me, yay, 4. Now it's balanced. Now I can move on to my oxygens. Well, I put this 2 out here already, so that means I have 2 oxygens. And coming across over here, this 2 applies to everything inside the parentheses, so I have 2 oxygens over here, and everything is balanced. Yay. Okay, we'll do one more example on here, and then I'm going to call this quits, and I'll do a second part to this set of notes because I don't want these to be too long. So, solid zinc metal reacts with aqueous copper 2 sulfate to produce solid copper metal and aqueous zinc sulfate. So I'm going to start at the beginning. Solid zinc, Zn, solid, reacts with aqueous copper 2 sulfate. So copper 2 means that we have copper 2 plus, and sulfate, SO4, has a negative 2 charge. Well, 2 and a 2 means they just balance each other out. So Cu SO4, and then it's aqueous, so AQ. To produce solid copper, so copper all by itself, and aqueous zinc sulfate. Well, if you remember, zinc has a plus 2 charge. Sulfate hadn't changed, so it's still a negative 2 charge, and they also naturally balance each other out. So zinc sulfate, and this would be aqueous. Now, looking at this, I'm going to start with my metals. Well, I have 2 metals, so which one of the 2 should I start with? Truth, it does not matter. Just pick one. I always tend to start with the first one I get to. So the first metal that I got to was zinc. Well, you see I have 1 zinc over here, and I have 1 zinc over here. So yay, they're naturally balanced. Then I'm going to move on to my copper. And you'll see that you have 1 copper on the reactant side, and come over to the product side, and you've got 1 copper. So they are also naturally balanced. Then the next step after metals is your polyatomic ions. And you can see here, and it's polyatomic ions that go from the reactant side to the product side without changing. If they changed, then you can't balance an ion as a group. You'd have to balance the individual elements in the ion. But these guys stayed together. So I can say, how many sulfates do I have? And you might be tempted to say, oh, I have 4 sulfates. Well, no, because a sulfate is an SO4. The 4 is included into the oxygen. But this whole thing makes up 1 sulfate. So on the reactant side, I have 1 sulfate, and on the product side, I have 1 sulfate. Don't let these subscripts mess you up. If you have more than 1 polyatomic ion, then you're going to have parentheses. And so this reaction is actually naturally balanced, and we don't have to do anything. And I'm going to go ahead and cut this one in half here, and I will come back and make you guys a part 2.